have a general formula for calculating atom. So we have A is equal to Z plus N, where A is the mass number, the Z is the atomic number, and the N is the proton number. I hope you know that. And if you are told to find the number of neutrons, you have to make N the subject. You can make N the subject by transposing the atomic number to this side. So just write A minus Z is equal to N. I hope you can do it. This one is simple. I hope you can do it. Now, if the atom is in a neutral state, the number of electrons is the same as the number of protons. Now, somebody can ask you, if the atom is not in the neutral state, how can you write the atom? So, now, look at this element. This one is sodium. And we have here 2 plus. It means that this atom has lost 2 electrons. So, if the atomic number of sodium is 11, you deduct 2 from the 11. So, if you are told to write down the atomic number of sodium, or if you are told to write down the electron number of sodium, you just deduct 2 from the 11, then you get what? Your 9. If an atom gains an electron, it means that the atom has accepted more electrons to itself. So, for example, we have O2 minus. This one, the atomic number of oxygen is 8. And it has gained another 2 electrons. So, if you are told to write the atomic number, the electron number of the oxygen, you just add 8 plus the 2, making 10. Take note of that. It is very important. But today, we are going to start a new topic. And the topic for today is conversion and conservation of energy. Conversion and conservation of energy. So, the word conversion, in simple definition, conversion, it means that here we are going to what? Convert one form of energy to the other form of energy. This one is simple, from one state to another state. For example, we can convert electrical energy to heat energy. By the use of what? Electric cooker. I'm coming. By the use of what? Electric cooker. And the next one, we have what? Conservation of energy. How can we conserve the energy we normally use in our various homes? Now, to preserve, the word conservation is what the same as preservation. How we can what? Preserve the amount of energy we use in our homes. Okay, it is very important. For example, if you are going to sleep, you can switch off all your bulbs so that at the end of the month you can pay a little amount of what? Light bill. If you are doing this, it means that you are conserving your energy. Now, if there is a lot of what? Block in the freezer, in your freezer, you can also what? Switch off the freezer. If you are doing this, it means that you are conserving the energy. You are conserving the energy so that at the end of the month you can pay a little amount of light bill. It is very important. So let us go to learning objectives for today. Learning objectives. So, learning objectives. After learning this unit, you should be able to, 1, list the various forms of energy. 2, Explain potential and kinetic energy. 3. Demonstrate how various forms of energy can be transformed. And 4. Give reason for conserving energy. It is very important because if they are going to set questions concerning this topic, they will base on the learning objective. So you have to understand it. So we are going to take them one after the other. So the first one, we are going to list the various forms of energy. So the first one is forms of energy. Forms of energy. Forms of energy. Forms of energy. So the same as types of energy. So this one is simple. So we have different types of energy, or we have different forms of energy. So we have energy exists in different forms. The various forms of energy are, first one is sound energy. First one is sound energy. We have chemical energy. We have electrical energy. We have heat energy, light energy, nuclear energy, solar energy, potential energy, and kinetic energy. These are forms of energy. So you can state 4 forms of energy or state 5 forms of energy. This one must come into your mind and you just write your 5 forms of what? Energy. Okay, so this one is very simple. So we are going to take them one after the other and talk about it. So the first one we are going to talk about was sound energy. Now we have a lot of instruments that produces a lot of sound. For example, we have trumpets, we have guitar, we have microphones, and so on. So we are going to talk about sound energy. We are going to talk about sound energy. Now you can see it on your screen. Sound energy is the energy produced due to the vibration of objects. So this is the definition of sound energy. If you are told to define sound energy is the energy produced due to the vibration of objects. This is the definition. So if you are told to define, this one is simple. You have to define it. Now we have instruments such as guitar, loudspeakers, and trumpet produce sound energy only when they are vibrating. They produce what? Sound when they are vibrating. It is very important. It is very important, so we have to know. So some of the now loudspeaker, trumpet, and guitar produces sound when they are vibrating. For example, a bell ringing produces sound energy. A bell ringing produces sound energy. The plug strings of a guitar also produces sound energy. Now, guitar is always used in our churches, so I guess you know the strings of what? A guitar. Now, the next one is chemical energy. The next one is chemical energy. Chemical energy can be obtained from food, firewood, and it can also be obtained from what? Nuclear what? Reactions. Now, or chemical reaction. Now, let us talk about chemical energy. Chemical energy is energy produced as a result of chemical reactions or processes. For example, chemical energy is obtained from chemical reactions in dry cells. I guess you know dry cells or batteries. We normally use this one in our torchlight. Dry cells, you know it. This one is simple. This one is common to us. Dry cells, okay. Yes, we normally use this one in radios and torch lights. So, and we can also obtain chemical energy from food, firewood, and charcoal, as well as fuel, diesel, and that kind of all the chemical reactions also produce what? Chemical energy. Typical example is what? The LPG, liquefied petroleum gas, also produce what? Chemical energy. We have to take note of them. So the next one is electrical energy. electrical energy. Electrical energy. Electrical energy. Now, this one too is very important. Okay, electrical energy is energy produced as a result of the flow of electrical charges. So, back at electrons. Now, I want to demonstrate something. I want to draw something for you to understand. Now, we have the structure of atom. Like this, the middle part, at the center of the atom, we have the nucleus. And this one is the shell. We have the electron moving around the nucleus. This electron is very important if it comes to electricity. The flow of this electron produces electric current. And without a current, there will be no more, what? Electricity. So the flow of what? This electron produces what? Electricity. Okay. It is very important. Take note of that. And it passes through electrical conductor. And it always passes through electrical conductor. If somebody asks you what is a conductor, you have to define a conductor. A conductor is something that allows electricity to pass through easily. Okay, a conductor is something that allows electricity to pass through easy. Okay, so now, we have example is what? Aluminum or copper. Copper is a typical example of what? Electrical conductor. Okay, now, so electrical energy is the energy produced as a result of flow of charges. Okay, is energy produced as a result of the flow of electrical charges through a conductor. And a conductor is something that allows electricity to pass through easily. For example, electrical energy can be obtained from hydroelectric dams. Now, in science, the moment you hear hydroelectricity, hydro means water. It means that this electricity is obtained from water. This electricity is obtained from water. So hydro dams. The next one is heat energy. Heat energy is the energy which flows from one point to another, owing to a temperature difference. Now, for example, if I have a source of heat here, and I put a metal rod here. If I put it here is point A, and here is point A, and here is point B. So the temperature of point A will be different from the temperature of point B. So heat energy is the energy transferred from one place to another, owing to a temperature difference between them. So if the temperature of point A will be maybe 75 degrees Celsius, here will be 50 degrees Celsius, owing to a temperature difference between them. Heat energy. For example, the heat energy can be obtained from the sun. So like a solar energy. This is known as solar energy. The heat energy obtained from the sun is known as solar energy. And burning charcoal also produces what? Heat. Okay, so here in charcoal, the chemical energy in charcoal will be converted to heat energy as soon as it started what? Burning. The charcoal already contains chemical energy. So if you start burning the charcoal, the chemical energy in that charcoal will be converted to heat energy. Now, the next example of energy, the next form of energy is light energy. It's light energy. The next form of energy is light energy. It's light energy. Light energy is a form of energy that enables us to see or stimulate our sense of vision. Light energy is a form of energy that enables us to see or stimulate our sense of vision. So without light, you cannot see. That light we cannot see. And we can also obtain light energy from what? Fireflies. We have lamps. And so on. The sun also produces what? A lot of what? Light to the earth. So we have sun, we have stars, we have fireflies, we have electric and hurricane lamps and flashlights. All this produces what? Light. So without light energy, we cannot see. Without light energy, we cannot see. So the next form of energy is nuclear energy. It's nuclear energy. The next form of energy is the nuclear energy. So here we have a metal. It is very important. If a country is having this kind of metal in its soil, it means that the country is very rich. Now, we have uranium metal. This one is used in the production of a lot of weapons. And if you go to Western world, they normally use this one to generate electricity. We call this what? The nuclear power station. They don't use the hydro electricity. They normally use the nuclear energy to produce electricity. So nuclear energy is the energy produced by the splitting up of the nucleus of an atom or the fusion of the nuclei of two atoms. So assuming we have oxygen and sodium, for example, or let me take the uranium metal like this. We have the fusion of what? Its nucleus together to produce what? Large amount of energy. To produce large amount of energy. And this one is used to generate what? Large amount of electricity if you go to other countries. But in Ghana here, we normally use the hydroelectricity. That's we always obtain our electricity from what? Water bodies. That's why we normally use the Akosombo Dam. Okay, there we have some turbines over there that moves. That generates what? The current of what? The electricity. So, but if you go to other countries, they normally use the nuclear power station to generate high amount of electricity. So this one is very simple. Amount of electricity. In nuclear power stations, the heat energy required to produce steam is provided by a nuclear reactor. It's very important. This one is very important. For example, it's what the uranium metal. So you need this before you can produce that amount of energy. And this one is normally used to produce the atomic bombs, bullets, drones, and other kind of dangerous weapons. So a country like Iran, North Korea, so you can see always news, you can see on the television, this country is producing this kind of nuclear weapon. This country is producing because they have this metal in abundance. So let's go to the next form of energy. The next form of energy is solar energy. Is solar energy. You all know the definition of solar energy. Solar energy is energy obtained from the sun. Solar energy. Now, most of the energy we use on Earth comes from the sun. This energy is called solar energy. This energy is called solar energy. Green plants use solar energy to produce their food. And this process is known as photosynthesis. So the sun is very important. The sun is very important. So without the sun, the plant cannot manufacture its own food. And we all depend on the sun for survival. We all depend on the sun for survival. So the plant use the sunlight to produce its own food. And after that, we also go there to what? To harvest the food produced by the plant. So we all depend on the plant for survival. So the sun energy is very important. And the sun energy also what? Produces what? Vitamin D, which also boosts the immune system. It is very important. Which also boosts the immune system. So the next energy is potential and kinetic energy. The next form of energy is potential and kinetic energy. Now, let us take them one after the other. What is potential energy? Potential energy. Potential energy. Potential energy is the energy possessed by a body by virtue of its position. By virtue of its position. By virtue of its position. So, the position of, if you put, for example, if you put a book on the table, the energy possessed by that book on that table is potential energy. Now, when a mango hangs on a tree, that energy possessed by the mango is potential energy. If you put a stationary chair at a place without moving the chair, the energy possessed by that chair is potential energy. And if you lift up a chair like this, the energy possessed by this chair is potential energy. So potential energy is energy possessed by an object or a body by virtue of its position. By virtue of its position. That's potential energy. But I'm going to talk much about this potential energy because we have some formulas there and we have some calculations over there too. So, for example, a hanging fruit on a tree has potential energy. I told you. So, potential energy of a body is given by potential energy of a body is given by the formula mass times the gravity times the height. This is the formula for potential energy. So here you write P G is equal to M G H. So this is the equation for potential energy. So in science, if you are told to define potential energy and you don't know the definition, potential energy is the energy possessed by a body by virtue of its position. And if you remember the formula like this, you can write P is equal to mass mgh, where P is potential energy, M is mass, G is gravity, and H is height. And H is height. But if you write this one, what is potential energy? Write down P is equal to mass mgh. This one is wrong. So the moment you write this, you have to take your time and explain where PE is potential energy, M is mass, G is gravity, and H is height. So this one is accepted. This one is accepted. Now, and potential energy is also measured in joule. Potential energy is also measured in joules. So take note of that. Take note of that. Now, let us go to another point. Now, here, this is the formula for potential energy. Now, in a question, you can be asked to find the mass. You can be asked to find the mass. You can be asked to find the height. So, the first one, this one is equation 1. So, let us go in for equation 2. So, if you are told to find the mass, you have to make M the subject. You can just make M the subject by dividing both sides by gravity and height. So here you divide both sides by gravity times the height. Gravity times the height. So that this G will cancel this H will cancel this. So our mass is equal to potential energy out of gravity times the height. So our mass is equal to potential energy out of gravity times the height. So this one is equation 2. So if you are told to find the mass, they will give you the potential energy. Gravity is always constant, which is 10 meters per second square, and they will give you the height. So use this formula to calculate for the mass of the object. Now, let's go to equation 3. Let's go to equation 3. So you write down your formula again. PE, this one is the original formula. PE is equal to mass times the gravity times height. So here, you are looking for the height. So you have to make H the subject. You can make H the subject by dividing both sides by the mass times the gravity. So here, you divide here by M. G. Here to divide both, you divide it by mg, so that this m will cancel this m. We have J will cancel J, leaving the H. So our H is equal to potential energy out of mass times gravity. So if you are told to find the height of the object, the potential energy will be given to you, the mass will be given to you, and the gravity is constant, which is 10 meters per second square. Okay, so this one too is our equation 3. Let me explain it again. So here, potential energy is equal to mass times the gravity times height. I hope you can see it. And if you are told to find the potential energy, you just write down the formula straightforward and put in the figures. In the question, they will give you the mass, they will give you the gravity, and they will give you the height. And you can be told to find the potential energy. So if you are told to find the potential energy, just write down this formula and put in the figures. And after that, you just write it in what? Joules. Okay, this is the unit of potential energy. Now, if you are told to find the mass, here we have PE is equal to mgh. So this one is simple change of subject. So here, if I told to find the mass, this m is multiplied G and h. We have m times G times h. So if I told to find the mass, you have to divide both sides by gravity and the h, so that the m will stand alone. So here, you divide both sides by gravity times the h here. Okay? So that this J will cancel this J. And we have H here, Here we don't have M here, so this H will cancel this H. So we get So here too, you divide both sides by gravity times the height. Okay. Here we have gravity. Here we have potential energy. So they cannot cancel each other. So our M is equal to potential energy out of gravity times the height. This one is used to create that half from your mark. So it is very important. It is very important. So this is how we find the mass of an object when a question is given. The next one is the height. The height too, you write down the formula. So PE is equal to mgh. Here we are looking for the height. The same procedure. You divide both sides by the mass times the gravity. So here you divide it mass times the gravity here. You divide here mass times the gravity. Okay. So we have m here. We have m here. So this m will be omitted. We have g here. We have gravity. We have gravity here. So this gravity will be omitted. So our H is equal to potential energy out of mass times the gravity. But don't forget that the gravity is always constant. The gravity is 10 meters per second square. So the gravity is equal to 10 meters per second square. Or you can also write it in this form. Meters per second square in this form. This one is the unit for the gravity. So this gravity is always constant. Okay, so in a question, after writing everything, they will give you take J. Take J is equal to 10 meters per second square. So you just put in your figures. It is very important. Okay, so you have to put it in your mind that always the gravity is 10 meters per second square. So as soon as a question is given, either potential energy or either you are told to find the height or the mass, remember that the gravity is always 10. The gravity is constant. The gravity is always 10 meters per second square. It is very important. So here, the first formula, we have potential energy is equal to mass times the gravity times the height. Now, you go to the mass is equal to a potential energy out of what? Gravity times the height. And the last one, which is the height, is potential energy out of mass times the gravity. So it will depend on the question. So you have to take your time and read through the question. So understanding the question is part of the exam. So if a question is given, take your time and read through the question and list down the parameters. If a question is given, you have to make sure that you list down all the parameters. The parameters will help you to solve the question at ease. Solve the question at ease. So assuming a question is given and you are told to find the potential energy. Now, you all know that the formula for potential energy is mass times the gravity times height. Now, this one, we have to read through the question. If you can list down the parameters. Based on what? Its unit. So mass, you know that mass is measured in what? Kilograms. So maybe 15 kilograms. So it means that the 15 kilograms stand for the mass. So you just write M is equal to 15 kg. We have height is also measured in meters. So maybe 4 meters. So we just write to 8 here, 4 meters. Okay, and the gravity is always constant. After writing the question, they will give it to you. Take J is equal to 10 meters per second square. So you just write your J is equal to what? 10 meters per second square. So find the potential energy. This one is simple. So you just write down the formula here. You put in the figure. So here we have mass. We just write it 15 times the gravity, which is 10. times the height, which is 4. Okay, so here you get this one, 150 times 4. Okay, 150 times 4. You just write down your answer. And don't forget that the answer is measured in what? Joule. The answer is measured in joule because it's what? A form of what? Energy. The unit for the SI unit of energy is joule. So after calculating what? The question, your answer must be in the form of what? This unit. If you fail to bring it, they will just mark the first one as this one. You have put in the figures. They also mark it for you like this. Here, they will mark you and they will return mass from it. So after writing it, this one will give you what? 600 joule. So if you write only 600, here they will deduct mass from your answer. So here you got 2 marks here. Instead of what? The 2, you don't get all the 2. They will also what? Deduct mass, so you get 1.5 out of the 2. So if you're able to write down the units attached to the figure, this one today will mark it M1. So normally, this question, they will just, it always produce what? 3 marks. So if you fail to bring what? The units, if you just write 600, 600 is just a figure. 600 is a figure. So if you write 600, they will mark you wrong here, and they will deduct some marks from you. So you have to pay attention. So pay attention to what I'm saying. It is very important. So we are going to continue next Wednesday. We are going to continue on Wednesday. Wednesday, we are going to solve some calculations involving potential and kinetic energy. And it demands a lot of time. So on Wednesday, I want you to pay attention. I want you to be with your phone on time so that you can catch up the lesson. Thank you.